Somewhere out in the constellation of Cygnus, 600 light-years from where you're sitting right now, there is a planet almost entirely covered in ocean. Not a shallow sea, a single global ocean, hundreds of kilometers deep, crushing darkness below and open sky above, with something possibly moving in the water between the two. That planet is Kepler 22b, and it might be the most haunting world ever found. But we'll get back to it. Let's start close. 39 light-years away, which in cosmic terms is practically your backyard, sits one of the most studied systems in modern astronomy. 7 rocky worlds circling a single dim star, 3 of them locked inside the habitable zone where liquid water could pool on a surface and stay there. This is Trappist 1, and it has kept researchers awake for years. The star itself is a red dwarf, cool and small, roughly the size of Jupiter. That means all 7 planets huddle in tight orbits, so compact the entire system would fit inside Mercury's path around our Sun. That closeness creates something remarkable. If you lived on one of these worlds, the neighboring planets wouldn't be distant lights. They'd hang in the sky like enormous moons, close enough to resolve continents with the naked eye. You wouldn't take a flight between countries. You'd launch between planets. And here's a detail that doesn't get enough attention, because these worlds are so gravitationally intertwined, orbiting in near-perfect resonance with one another. The tides on each planet would be extraordinary. Not the gentle coastal tides we experience here on Earth, but massive, rhythmic swells driven by the gravitational pull of several neighboring worlds at once. If life evolved in Trappist 1's oceans, it evolved in a very different kind of ocean to ours. Trappist 1e is the one scientists keep circling back to. Slightly smaller than Earth, conditions favorable for liquid water, and early evidence suggesting an atmosphere thick with oxygen. But there's a catch the travel brochure won't mention. The planets are almost certainly tidally locked. One hemisphere baked permanently under starlight, the other frozen into a dead winter that never breaks. Life, if it exists there, would be concentrated in a narrow band around the Terminator line, a ring of perpetual twilight, neither scorched nor frozen. Strange, thin, possibly thriving. Now take everything you just imagined and scale it up. Meet Kepler 452b. Astronomers called it Earth 2.0, and the comparison actually holds up. It orbits a sun-like star on a 384-day cycle, just 5% longer than our year, close enough that adjusting a calendar wouldn't take much. It sits comfortably in the habitable zone. It's rocky, and structurally, it rhymes with home in a way that feels almost intentional, except it isn't quite home. Kepler 452b is 50% wider than Earth, but 5 times more massive, which means gravity on the surface runs about twice as strong as what you feel right now. Every step would cost double. Your body would work harder just standing still. Elite athletes here would be ordinary people there. The landscape would be flatter too. Mountains can only grow so tall before gravity tears them back down. So instead of dramatic ranges, you'd get wide, sprawling lowlands and enormous shallow basins. And think about what that does to the biology. Every creature that ever evolved on that planet would be built low and dense. Nothing tall, nothing fragile, no towering trees, no long-necked grazers reaching for high canopy. Evolution under twice the gravity doesn't produce the same solutions it found here. It produces something sturdier, more compressed, more deliberate. If intelligent life emerged on Kepler 452b and somehow looked up at the stars the way we do, it would have had to work significantly harder just to get off the ground. The rocket equation becomes brutal when your gravity well is twice as deep. Maybe that's why we haven't heard from them yet. Its star is also aging. Sun-like stars grow more energetic as they get older, and Kepler 452b's sun has had longer to change. The planet may already be absorbing more radiation than it can comfortably handle, slowly tipping toward a runaway greenhouse spiral, the same process that turned Venus from a potentially habitable world into a crushing 465-degree oven. Whether Kepler 452b is early in that process or deep into it, we genuinely don't know yet, which brings us to the most quietly extraordinary world on this list. KOI 5715.01, yes, the name is terrible, is 3,000 light-years away and almost certainly unreachable within any human lifetime using any technology we currently possess. In an Orion spacecraft, the fastest crewed vehicle ever seriously designed, the trip would would take over 100,000 years. And yet, scientists consider it the single best candidate for a superhabitable world ever identified. It orbits an orange dwarf star, a class smaller and cooler than our Sun, but extraordinarily stable. The kind of star that doesn't flare violently, doesn't age into a red giant on a 10 billion year clock, but instead burns quietly and steadily for up to 70 billion years. Our Sun is 4.6 billion years old, with roughly 5 billion left. KOI 5715.01 star could outlast our entire solar system's lifespan 7 times over. Life on Earth has had 4 billion years to get from single-celled organisms to space telescopes. Imagine the trajectory of life given 70 billion years of uninterrupted evolution on a stable world twice the size of ours. Whatever that looks like, we don't have a word for it yet. And the size matters more than you might think. A world twice the size of Earth doesn't just mean twice the land. It means more geological activity, more volcanic venting, more of the raw chemical energy that life tends to feed on in its earliest stages, more tectonic movement cycling nutrients back to the surface over billions of years, more coastline, more shallow sea, more of the exact environments where complexity tends to emerge. Earth got lucky with its size. KOI 5715.01 didn't get lucky. It got generous. The unsettling thought is that compared to whatever might be living there, we might be the primitive ones. We showed up 4 billion years into a 10 billion year window. They may have been building civilizations before our Sun even existed. And then there's Kepler 22b, back to where we started. 600 light years away in Cygnus, a world that has no real analog in our solar system, a true ocean planet. Not a world with oceans on it, but a world that essentially is ocean, wrapped over a rocky core buried somewhere in the crushing deep. The surface, if you can call it that, would be featureless water in every direction, no continents, no beaches, just open sea and whatever lives beneath it. Scientists have speculated that life in those depths could be unlike anything we'd recognize. No photosynthesis, sunlight wouldn't reach far, chemistry-driven ecosystems clustering around geological heat vents, things built for pressure and darkness. If you want the most alien life in the universe, Kepler 22b is where you'd look for it. And in a strange way, we already have a small preview of what that might look like right here on Earth. In the deepest, most lightless trenches of our own oceans, creatures exist that look less like animals and more like fever dreams, translucent bodies, bioluminescent lures, eyes designed to detect the faintest imaginable trace of light. And that's what evolution came up with in just a fraction of Kepler 22b's available time, in just a fraction of its available depth. Scale that up, and the word creature starts to feel inadequate. 4 worlds, 1 tidally locked twilight ring, 1 double gravity Earth cousin, 1 70 billion year paradise we can't reach, 1 planet-sized ocean hiding something in the dark. Any one of them could rewrite everything we think we know. So here's the real question. If you could only visit one, which would you choose?